You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome. Today we're navigating some really interesting shifts in cloud technology and cybersecurity. We'll pull out the key stuff from new platform features, security thinking, even some surprising developer war stories. The goal is simple: to get you quickly up to speed on what's actually important. Okay, let's kick off with something pretty big. Cloudflare Containers. They've hit public beta. The idea is deploying Docker images right onto Cloudflare's network, which is, what, over 330 cities now?
Yeah, it's massive. And the key thing here is how it plugs into Cloudflare workers. It's not just, another container service.
Right. It enables different kinds of apps.
Exactly. Think about running more complex Linux-based applications much, much closer to your users. We're talking lower latency for things like real-time AI, maybe interactive web apps.
And they have that scale to zero pricing, which is always nice.
Definitely. It makes these distributed edge setups potentially quite efficient cost-wise, too.
Okay, so that's edge computing moving forward. Now, shifting gears a bit, something potentially simplifying life for big companies from Amazon. Route 53 resolver endpoints. This sounds maybe a little dry, but I hear it tackles a real headache.
Oh, absolutely. If you're managing hybrid cloud networks connecting on-prem and AWS, this is quite significant. It's about DNS delegation for private hosted zone subdomains.
Which means
you can ditch a lot of those complex conditional forwarding rules you used to need. The if this, then go there kind of setup for DNS lookups.
Okay.
Now you can just delegate responsibility using standard name server records between your environments. It's just much cleaner for service discovery across that hybrid setup.
Simpler is usually better there.
Definitely. And just a quick aside, AWS also launched something called Model Context Protocol Servers, MCP, for some key databases like Aurora and DynamoDB. Looks like a tool to help developers build more sophisticated, maybe real-time features on top of their data.
Interesting. Okay, from infrastructure planning, let's pivot to security. There's a new model gaining traction, and also a bit of a warning note we should probably touch on.
Right. So first, there's this ZTB model from SigNoz that's zero trust, bring your own cloud. It's really relevant if you're deploying onto cloud infrastructure you manage yourself.
Zero trust is everywhere, but what's specific here?
Well, it has 5 core ideas. Things like data isolation, least privilege, encryption, the usual suspects. But critically, it emphasizes pull-based communication and component-level authentication.
Okay, pull-based meaning?
Meaning components don't just sit there listening. They only communicate when explicitly requested and authenticated. It tightens things up considerably, reducing the attack surface. It's about verifying everything.
Got it. And the warning note?
That comes from Cloudbees CEO Anuj Kapoor talking about AI and software development. He's pointing out that while AI can crank out code fast, there's a real risk.
Quality issues.
Yeah. Potentially opaque, hard to maintain code, maybe not well tested. He mentioned that after the initial, gold rush, companies are now becoming a bit more cautious, putting more guardrails in place. It's that classic tension between moving fast and, not breaking things too badly.
That balance is always tricky. Speaking of development choices and maybe pragmatism, let's talk languages. There's this idea of Go being an 80-20 language. What's the thinking there?
It's a really interesting design philosophy, actually. The core idea behind Go is to give you, say, 80% of the utility you need, but with only 20% of the complexity you might find in other languages.
So it intentionally avoids adding every possible feature.
Pretty much. Instead of constantly bolting on new things, Go prioritizes simplicity, stability, practicality. The result tends to be a fast, stable ecosystem that's, frankly, easier to maintain for developers and the people running the code. You get a lot done without getting bogged down.
Okay, that makes sense. Now, for something a bit different, a cautionary tale, perhaps. This story about an AWS Lambda silent crash sounds, concerning.
It is, yeah. It's quite unsettling. Basically, a startup found and importantly proved a silent crash happening at the platform level in AWS Lambda.
Silent meaning?
Yeah.
No logs, no errors.
Exactly. It affected Node.js functions making outbound HTTPS calls. The function would return a success response. Everything looked fine, but after that success, it would sometimes crash silently. No telemetry, no trace, nothing.
Wow. And AWS?
Despite really rigorous testing and escalating it properly through support channels, the company apparently got blamed for the issue. They ended up having to migrate their entire platform to Azure because they couldn't get it resolved or even acknowledged.
That's quite something. It really makes you think about platform reliability, doesn't
It
it?
absolutely does. It highlights these potential blind spots, what happens when things fail in ways you can't even see, and your provider doesn't see it either or denies it.
So wrapping this up, we've covered a lot today, from Cloudflare pushing the edge to AWS simplifying networks, new security models like ZTB, the whole AI code quality debate, and, well, this rather stark Lambda story.
Yeah, quite a range. And maybe the thought to leave you with is this. In these incredibly complex, layered cloud systems we all rely on, how do we even start to find these potential silent failures?
Good question.
What strategies do we need, maybe beyond standard monitoring, to build genuine trust and resilience when failures might not announce themselves, especially when the platforms themselves might have blind spots? Something to think about.
Spoken Tech for your ears.